Welcome to this episode. I'm Mira.
Hi everyone, I'm Jensen, glad to be here.
Today we're discussing an article titled ReFT, Representation Fine-Tuning for Language Models.
So, the paper talks about fine-tuning language models, which is usually expensive, but they propose a new method called representation fine-tuning, or ReFT. It's supposed to be more efficient by manipulating model representations instead of weights. Could you tell us more about the main problem this paper addresses and what their contribution is?
Sure thing. The paper tackles the high cost of fine-tuning large language models. Their contribution is developing ReFT, which manipulates small fractions of model representations to steer behaviors at inference time, potentially replacing weight-based methods.
All right, let's dive into the ReFT methods. What are these methods all about?
Well, the ReFT methods are designed for transformer-based models, focusing on manipulating contextualized token representations rather than weights. They work with both autoregressive and masked LMs.
Oh, interesting. Can you explain the motivation behind these methods?
Absolutely. The motivation comes from causal abstraction in interpretability research, using interventions to understand the causal role of representations. It involves fixing representations to counterfactual values using low-rank projection matrices.
Got it. And how do LoReFT and DiReFT fit into this picture?
Yeah, so LoReFT uses a low-rank matrix to edit representations guided by task labels, while DiReFT simplifies this by removing orthogonality constraints to speed up training.
That makes sense. Simplifying things can really help with efficiency. So what's the training objective for these methods?
Good question. The goal is to modify the distribution over token sequences induced by the pre-trained LM, aiming for effective language modeling and classification tasks.
Let's talk about ReFT intervention. How does this method work?
Right. ReFT intervention modifies hidden representations during the forward pass, defined as a tuple that specifies where and how to intervene in the model's layers.
And how does LoReFT specifically implement this intervention?
Oh, LoReFT restricts edits to a subspace, minimizing cross-entropy loss with teacher forcing. It adds a classification head for single-label tasks.
What about the generalization of these methods? How do they define interventions broadly?
Yeah, generally, interventions are tuples defining representation modifications at specific layers and positions, affecting subsequent computations.
Now, onto experiments. How were ReFT methods evaluated against existing techniques?
The experiments compared ReFTs to other PEFTs across diverse NLP benchmarks, using various model sizes and focusing on performance and parameter efficiency.
How did they handle hyperparameters in these experiments?
Well, they tuned 4 hyperparameters like prefix and suffix positions and simplified the search space compared to LoRa, tuning on development sets.
And what were the results for common sense reasoning tasks?
Oh, LoReFT achieved state-of-the-art performance, outperforming other methods